All right, perfect. Okay. So basically, we will start with what A/B testing is and why companies want to do it, et cetera, et cetera, right? And the concept of A/B testing comes from statistics, basically, and we'll have to touch a little bit on statistics also. But we'll not go too deep. We'll mainly focus on the tech part. The statistics part we'll do it later in a different series, right? So this session is more about pipelines. This series is more about pipelines. So we'll stick with the tech part. Okay. Now, with that said, okay, let's understand what A/B testing is, why companies do that, and why respected also machine learning engineering to understand how it works, etc. Right? So basically, A/B testing is nothing but testing two different versions of something, right? Like different models, or if you're just let's say you're thinking of buying a car or selling a car, which color car is going to sell faster? Okay, so will it be a black color? Will it be a yellow color? You don't know, right? Like you want to kind of do an experiment based on that, and that is called basically choosing between this or that, right? So A or B, choosing between A or B, and kind of going with that is basically A/B testing. Okay. Now, when it comes to web uh, properties, websites, etc., when they release a new feature, right? Let's say they've come up with a new feature, a different button or a different image or whatnot, right? So they'll usually keep everything else the same and only change that button ka color or something like that, right? So or some slight difference. So basically they want to just specifically test the effectiveness of this particular feature versus a different feature or upgradation. Okay. So that is what is called as A/B testing. So you're basically keeping everything else constant, but you're only changing some small things, two things. Okay, this is the ideal scenario for A/B testing. Unfortunately, or whatever, practically, what happens is you can't control other things, right? So other things keep changing. So as a result, what happens is you don't get perfect background conditions. Okay, so you'll have to figure out a statistical, uh, like literature or something, and see if what happens if the background has changed a little bit or that sort of thing, right? So I hope you guys are getting my drift, right? You catch my drift. So essentially, what we are saying is to do a really good A/B test, you have to make sure everything else in the background is similar. Only the piece that you've changed has to be uh, different, right? So for example, once you change a button, you want to keep everything else same for and randomize it. Okay, you can't like show one model for people in, let's say, a particular country and a model B for people in different country. You shouldn't do that. Then because then you're introducing additional variables, right? So you don't want to do that. So you want to be making sure that for both the countries, you're randomly picking the population. The keyword here is random, right? There should not be anything that is overlapping in the population sample. That is when you're getting a real A/B test, right? Now, there is also, so that is a step, that is how you frame the experiment. Then the second step is, or the end result, how do you measure the success of model B versus model A, right? So let's say in case of machine learning, usually the success metric is what? Accuracy, right? So let's say the accuracy of model A is something like 94%, and then model B is slightly higher, let's say 95%. Now, is it possible that the model B got this slightly higher percentage by pure luck or randomness, right? So there's something called a concept of statistical significance. Okay, so ultimately the results have to be passed through the statistical significance test, or so-called p-test. Okay, and you have to measure that, and only then will you actually infer that the model B is better than A. All right. So this is the framework, how you frame an experiment for the A/B testing. Having said that, we're not going to go into the statistics part because we are primarily focusing on the technical part. All right. Okay. So let's move forward. So here's our architecture diagram, right? So by the way, any questions so far? All right, let's move ahead. So essentially, um, basically what is happening in this particular case, in the previous session, we talked about endpoints, right? What we are doing in this particular architecture is that we are using the same endpoint, but the traffic will be routed in a random fashion. So let's say 10 inference requests come. We will route 5 to model A and we'll route 5 to model B. Okay. And we'll observe how they're performing for these different inference requests. And we'll also observe a bunch of other things, which we'll see in this session, right? So essentially, that is what we're doing. So you get this your inference comes to the same endpoint, it gets routed to model A and model B randomly, right? And we're going to measure the effectiveness of what things look like, right? With that said, this is how it is, right? So like I said, there's an endpoint, there's a model A, model B. You give 50% to model A and 50% to model B, right? And then you start measuring metrics and decide finally which is better. Okay, so with that, let's walk through the code. So this is a typical code we've already seen multiple times. You want to get a session, role, region, bucket, etc., etc., and you're going to excuse me, I have a little bit of cold, so I'm not able to speak properly. So you're going to then start the creation of endpoint, right? So we are now creating a variable called autopilot. Okay, we're just trying to see if it's already there. It's not there, which is good. Now we're going to create another variable called training job. All right. So that we are creating by we are picking it from the stored one, so that we don't have to reinvent the wheel. So this is already there, so we're going to just take that, right? So like yesterday, we're also getting the model from the model registry or where we have stored it, right? We're getting it from the bucket basically, not from model registry. We're untarring the model, and then we are basically looking at the model signature, right? So like we did yes in the previous session, we're going to check the signature to make sure everything is looking fine. All right. Now once that is done, just like last session, we have the same inference file .py file. That's not changing. So everything is pretty much the same for a single endpoint or a A/B testing. The difference comes later, right? Now in the following steps is where the difference comes. So the inference file .py is also pretty much the same. Now, here's something different. So we are basically also creating, we're basically in this particular case, we are getting a URL or an image that we're going to use um, in the cluster, right? So essentially, we're asking to get this. We're asking Amazon AWS SageMaker to give us this image, this TensorFlow, the model version, Pi37, and the instance type. So this is what we want. This is what we're asking them, and we got this, right? So FailMaker is giving you saying this link saying, hey, this is where you want to get it, right? From this we're getting it. Okay. Then we get the same thing. So we're getting a training job. From here on, it actually starts, right? Oh, guys, I'm not able to speak properly. Anyway, so we are here. What we're doing is we're creating model A and model B. Okay, so we are naming them slightly differently. We're going to call them model B and model A, and we are going to then route the traffic randomly. That is the key difference here. Okay, this is all you need to understand. Okay, so like basically, if you check this particular code, right? SageMaker has actually done a lot of work for us, so we don't have to do much per se. We just have to call the right API. So we are going to call this production variant function, and we are passing in two names, model A and model B. All right. So they have the exact same instance type and instance count and everything. And initially we're starting with 50%. All right. So basically, so the data gets routed equally. So if 10 inference requests come, they get routed equally and they get passed to same equally randomly. By the way, it's not like there has to be randomness like we discussed previously. It's very important to have that randomness. So this is where we can see check out the REST endpoint. Let's go check it out. Just 1 second. It's already there. So it's already there. It's already servicing and everything is going fine. right? So just check it out. Okay, the CPU utilization, everything is fine. So by the way, the reason why we're getting two CPU utilizations is because we have two instances now, right? So it's showing us statistics for those two instances. Okay, since we created a production variant, there's like two variants now, variant A and variant B, right? Just like we wanted, and the distribution is given here, right? That is the cool part. Okay, now let's go ahead and maybe test it. Okay, so these are other things we want to track. So as a part of experimentation, right? By the way, guys, why are we doing this? Why are we doing A/B testing? Why are we calling it experiment, right? The reason is this is the crux of data science. In data science, you're constantly developing new models, and that development of new models, testing them out is called an experiment, right? And we have to track them. We have to track all the experiments effectively, efficiently, right? And that's why you have this whole SageMaker setup, right? Otherwise, we don't need this. We can just use a Jupyter notebook. But because SageMaker, we want to run experiments, we want to track all the results, we want to compare them. That is why we have to learn SageMaker and understand how SageMaker pipelines work and all that, right? So having said that, so we are now running a trial, right? So in an experiment, we discussed this previously, right? In the next given experiment, there's a concept of trial, and then every time you run it, it's a new trial, right? That's the point there. Uh, so now this is already deployed, so that's why you're seeing that. And all I'm going to do this time around is basically we're going to simulate a prediction, right, from application. Okay. Um, okay, I'm like yesterday, I'm gonna run this uh, simple text from my side and see if it's getting predicted. It's getting predicted, right? So the moment I hit this, I think I'll see a slight change in the CPU. Let's see if it's happening. Uh, sorry, not this one, right? Okay, there's hardly anything because I think the data is too low, all right? So let's try with slightly higher, a bit more data. Yeah, this one, let's give it a try. Okay. Yeah, I think it'll take a little bit of time for us to show the results, right? So maybe we'll just zoom in this. Yeah. So I think I see that there's a slight spike here in CPU utilization and memory utilization. So it'll show up a little bit later. Now, having said that, let's start looking at the uh, performance metrics. So this is very useful. So since I've already done this, you don't I'm not going to run this again. But essentially, it's showing me all the different metrics for model A and model B. That's what it is, right? Okay. This is a small function called sleep function. This basically stops execution because sometimes what happens is the model might not be updated. So we use this, but I would say 20 seconds is probably too much. 10 seconds is enough. So excuse me, guys. I'm sorry. Okay. So let's run the other ones. So here we are looking at CPU utilization. As you can see, the model A and B both have similar CPU utilization, which is expected because the traffic is getting distributed equally, right? That's a good point. Now look at invocations, meaning how many times are we calling, right? That too is roughly the same. This here is 6, the other one is 5, right? So okay, 6 for both of them, which is good, which is good. Okay. Invocations per instance. I think this is also going to be the same. Yeah. All right. Okay. So this is model latency, which is basically a measure of how fast the model is reacting. See, by the way, in this particular case, we are using the same model, right? So it's not like a different model. So you shouldn't see any difference per se. All right. And the reason why we're doing that is because we're just trying to run A/B testing with different instances. We're not trying to actually, we're not doing a real experiment wherein we're comparing two models, right? We're not doing that. So that's why we're using the same model, but that way the management is easier. We're not going to see a difference in the results, basically. We're just going to see technical difference. Okay. Now, this is the interesting part. So just by updating the desired weight, we can actually change traffic between A and B. So previously it was 50-50. Now let's make it, like 0 and 100, right? So model B gets 100 all of the requests, and model A gets none of the requests, right? This is basically updating the endpoint itself. Just by running this code, you're able to, you know, uh, update the endpoint in production. Okay, that's the that's the super powerful thing, right? We're not bringing down the instances, we're not doing anything in production. Right, in production you're able to do this, which is a very powerful thing. Okay, uh, that's the power of SageMaker, right? I think there's other ways of doing it. There's something called blue green, yeah, blue green deployment and all that. So that will, it's not now, but we'll discuss later. So as you can see here, it's updated, right? So we changed those instances and it's updated. Now, once we finish this, we can actually run the same prediction. Next time around, you'll see the instances, invocations, and CPU utilization will be different. So model A will have 0, model will have everything, because we are now routing the full traffic to model B, right? Okay, yeah. Now let's actually test this out, okay? Uh, so we're going to run some more predictions. Uh, mhm. All right. Let's send some data to only model B. Okay. I'm going to hit the predict button again. Okay. So in the, okay, this is where it is, right? Yeah, this is the one. This is the one. Yeah, this is the file and everything. And from here, I'm going to hit the predict function. So this is where the predictor, yeah, this is what we need, right? So once I send like 10 invocations, you will see that all the invocations will now go to B and none of them will go to A, right? So you see this same predictions like in the last session, 5, 5. So it's almost perfect. That's a very powerful thing. Very cool, very cool. Okay. Let's now get the metrics again. We'll see the metrics being slightly different, right, this time around, because only B is getting all the traffic. Okay, we've gotten that. Let's run this now. CPU utilization. Hmm. Yeah, you see this? Variant B is getting all the invocations, right? See here? So that's what is happening, okay? So basically variant B is getting all the invocations, variant A is getting none of the invocations, because we changed the setup, right? So you see this clearly here. Same thing, invocations, for instance, I would say it's going to be the same thing effectively. You're not going to see any difference, right? Yeah, again, B is getting all the inference requests. A is getting nothing. Because what that means is the CPU utilization eventually of A would be much lower, right? Okay, let's run this. Yeah, same thing, right? Perfect. So the CPU utilization of A is fallen drastically. All right. We see that B is getting utilized a lot more. And the reason is simple, right? Because all the traffic is now going to B and nothing is going to A. All right. Um, all right. So the last bit is model licensing. Let's just run this. And I think then we can actually will run anything else, right? So the model, yeah, the latency for B is very high, and A is nothing, because there's no model on A. We're not serving it at all. All right. So that's it. Now we'll have to basically close this, right? So we can actually now change the variations again. From 0 and 100, we can actually go back to 50-50 or whatever, right? It's up to us now. Okay. Now we can actually remove. We can even remove the A, right? Basically, how do we remove the A? It's very simple. All you say is um, write the function again, trigger the function again, the create endpoint config, but this time only keep B. Just remove A. That's it. So we don't have to, there's no delete A. We just say keep B when we update the endpoint. Once you do this, what happens is basically A is no longer there. We'll only have B. Okay. You have to wait a little bit time because it takes some time for this thing to get updated. Yeah. Any questions so far, guys?
No, Krishna.
Yeah, we'll have to wait till the endpoint is completely updated. So once this is updated, you will see that uh, the A is no longer there, right? Because we removed the variant A. Let's see if that happens, yeah. So let's check out all the metrics that we're getting here. So we have the name, we have the ARL, we have the URL, basically the endpoint, right? We're also capturing few other data points here. There's obviously Cloud Monitor, Cloud Watch, and we're getting all the results from that, right? And apart from that, we have the variants, we have endpoint configurations. Um, there's something called shadow. So basically, you can also run a shadow version. There's production and shadow. Production is like you are basically serving requests, right? You can run a shadow deployment wherein basically it's not going to be served in production, but it will be like it'll be used for measuring things, right? So um, that's called as a blue-green deployment or something, right? So essentially, the new model will be in shadow, and you will not show the results to the users because you want to test it out for a few days or weeks to be confident that the new model is really performing better and secure and there's no bugs, etc., right? So these are all very important concepts when we go into production because in production, this is a cost for making mistakes, right? If you serve a wrong prediction to the user, a lot of bad things can happen. Your reputation is at stake. So in a high critical situation, you'll have the variant B in the A/B testing. You'll have the variant B in here, and so that you'll test it for a few days or weeks, and then make it to production. Okay. Uh, yeah, I think that's pretty much it, right? So yeah, it's now successfully deployed. Let's see what is happening because we removed the A part, right? Let's see if it is actually removed or not. Yeah, so the variant A is removed because we said we only want variant B. Okay. Now, yeah, so from here itself, I can actually update the weights, instance counts, config, auto scaling, and all that, which is very, very cool, right? I can do auto scaling from here. So I can say, hey, this is my minimum instance, that's my maximum instance, which means in case there's a lot of traffic, it automatically scales basically, right? That's the and SageMaker has many built-in scaling policies, different scaling policies. You can use those also. Um, yeah, I think we're kind of done with the demo. So we've seen what A/B testing is and how you deploy two different variants of a given model, and then how you change the traffic between uh, these different variants, right? Yeah. So now I think we can go ahead and remove the we can release the resources. This is basically I can remove this endpoint. Okay. Now the endpoint is removed, and we shut down this notebook. Right. If we run this again, the endpoint will be gone. Yeah, that's it. All right. All right. So, any questions on the concept or anything like that?
Krishna, while we are dealing with these scenarios, when we are, let's say, we are dealing with big data, in such scenario, what are the precautionary steps we have to take into consideration?
So while dealing with big data, what are the steps you have to take into consideration? Is that your question?
Yeah, yeah.
Yeah. So basically, whatever you're doing right now is for big data only. Okay. See, the whole concept of SageMaker is for production level scaling and a lot of data. Okay. Uh, that's why there are so many features like auto scaling, etc. So you can enable auto scaling in the endpoints. And then what happens is if there is a lot of data coming in, inferences, requests, right? So let's say there's a spike. SageMaker will spin up more clusters. The same type instance type, they'll spin up more clusters. So you don't have to worry about that. That's the superpower or use case of this.
Okay. That's what the thing I want to know.
Yeah, yeah. So I mean, this is actually very important because typically training is something you do by yourself, right? In case it's not a online training or online learning, right? So let's say you train the model by yourself, that you've done with existing data and you know how much data you have. Whereas for inference, you don't know because maybe your model gets very popular. These days, there's so many AI applications, right? Like faces, morphing, this, that, what have you. They're all basically AI models ultimately. Okay. And let's say some app of yours gets popular, you get a lot of data, essentially a lot of hits. The hits are nothing but inferences, right? So inference requests. Okay. So essentially, uh, you want to have some sort of scaling mechanism for your inference endpoints, right? And that's why SageMaker is very powerful because it has an auto scaling. It has different variants of auto scaling you can use so that your users don't have to face the waiting times and all that. Basically.
I don't know. This is the right platform to put my weird question.
Sure, go ahead, go ahead.
So, if it is quantum computing comes into existence, okay,
Mhm.
like it means like the data pumping is too high.
We don't have to go to quantum computing, man. Like somebody could be a hacker and then they could just do DDoS, right? That happens all the time. So obviously that's a different that's a security and DDoS protection. It is SageMaker has that protection also. So essentially what SageMaker is doing, actually that's a good question, right? Um, so only thing is you have to frame the question differently. What happens if there's a DDoS attack? That's the question, right? So I mean, right now there is no clear answer because the current DDoS protection systems on AWS or whatever, they're all working in a mechanism of, hey, we're getting too much data, right? That's the only thing we look for, and they look for bots and all that. Whereas when it comes to inferences, it's always like it could be like, instead of uploading a kilobyte image, which is what we expect from the user, or let's say for 10 kilobytes, or okay, let's just make it 100 kilobytes, right? So a typical user is going to upload a picture of 100 kilobytes. What if they upload a picture of a gigabyte, right? Now that's also an attack. Okay, but the current DDoS systems are not really attuned towards that, which means you have to take care of that by yourself. So SageMaker, you'll have to figure out some way of rejecting the big image right at the endpoint level. Okay, that logic is you have to encode it. You have to figure out how to do it. Okay, because SageMaker is only uh, the normal DDoS protection that AWS offers is more about, hey, I'm getting 10,000 requests instead of getting one request a second or something. That's what usually DDoS protection, the current DDoS protection, look for, right? So you have to put additional things like this so that it's a bit of work because this is completely different domain from the normal work. See, 10 years back, there was no AI, there was no ML. We were just doing software applications and data. Now the world is changing, so we have to change accordingly.
So, SageMaker provides an facility like where I can whitelist specific API. I mean, specific customers where I expose my API. Something like that is possible with SageMaker.
So SageMaker has a concept of API gateway. So are you
Uh,
aware of API gateway?
Yep. Yep.
Yeah. So it has an API gateway. You can put an API gateway behind the endpoint. So then what happens is you can put custom rules on API gateway, and that's how you
Oh,
can actually do whatever you do in the normal world, right? You can do it.
yeah. Yeah. Got it. Thanks, Krishna.
Perfect. Perfect, guys. I think this is a really fruitful session. So thanks for the questions, TG and